All right, my geometry. So this section, you're just going to watch this video. There's not much for us to do. It's kind of like a setup video for the next chapter. So 2.5 reasoning in geometry. So we're going to try to talk about like what a proof is, and we're going to talk about some properties that you might use in our proofs. When we do proofs in geometry, we're going to focus on parallel line proofs and congruent triangle proofs. That's the two types of proofs that you're going to work on, especially the congruent triangle ones. That's a big one in this class. All right, so we're going to look at a couple properties here that we should try to remember when we're doing these proofs. Now, to be honest with you, these first four, these are algebra properties. And again, this is how you solve equations, right? You add, subtract, multiply, divide both sides of the equation to manipulate it, not to change it. But again, usually you solve for x that way. The next four right here, these four are what I really care about. Okay. So the reflexive property, we will use this a lot. The reflexive property, I like to think of a mirror, right? So the left and right side of the equal sign equal each other. It's the exact same thing. You might say, well, that's stupid, right? What's the point of that? Well, we use that in congruent triangle problems all the time. So be aware of that. The symmetric property, I don't really care about. It's more of a algebra 1 concept, okay? The transitive property, I do care about a lot because we use that. Look at the way the transitive property works. So if A equals B and B equals C, then A equals C. What I like to think of is if two things, so A and C, both equal B. So if two things equal the same thing, then those two things equal each other. That's how I think of the transitive property. I also think of this B as the middleman. So we just cut out the middleman and we connect the outside things. So that's equality. And then also substitution. You use substitution all the time, right? When you create an equation, you plug values in. That's called substitution. If A and B are equal, then B can replace A, right? And that's the idea. And A can replace B, vice versa. Okay, now those three properties, reflexive, symmetric, and transitive, also can be used in congruence. And again, that's actually where we use the reflexive and transitive property more in congruence. So again, typically we're going to use two sides being congruent, and it's actually going to be a shared side between two triangles. So again, you'll see that when we get there in chapter 4. And then for the transitive property, most of the time we use it for angles down here. And again, we do that in parallel line proofs, so be aware of that. Okay. All right. And again, if you look at this transitive property, look here at this. Let's ignore this one right here. Oh, you know, I like that because they talk about the order doesn't really matter. Watch, right? So I actually like this. So sorry about that. Okay. So if we look at these two lines, right? Again, if A is congruent to B, if angle A is congruent to angle B, and angle B is congruent to angle C, again, there's that B and B. Cross them off. That means that angle C must be congruent to angle A, right? And again, it really doesn't matter the order. So in the second one, now we have angle B congruent to angle A and angle B congruent to angle C. So now we have A and C both congruent to B. So again, get rid of the B's. A is congruent to C. All right. So be aware of how the transitive property works. It's important. Okay, so 2 more slides left. So now, what is a proof? A proof is a convincing argument. We are going to do what are called 2-column proofs, which I will show you on the next page. But this is the idea. Each statement must follow logically from the steps before it. So it's this idea of building, right? We're building an argument step by step with justification. The justifications are your reasons in your proof. So we have a statement column and a reason column. Every statement needs a reason, a justification of why you say it. That's why I said from the get-go, vocab is very, very, very important. All right, so here is what a 2-column proof looks like. So you are given some information. You want this to be a lot of information. The more you're given, the more you have to work with. Then you need to prove something. Notice in your proof, the very first step is what you are given. And notice the reason is just the word given because that's how you know it's true. You're given it. The very last step is what you want to prove. However, notice that this last reason is not the word prove. It'll be some sort of a reason, like because of the definition of a midpoint, or because of the alternate interior angles theorem, something like that. Okay. And then again, the middle steps here follow logically from the previous statements. Statement, reason, statement, and reason. Do all proofs have 5 steps, Mr. Chappell? No. There's no telling how many steps a proof has. And you know what? If you see it differently than your friend, you might take 8 steps, they might take 4. So it's not an equal idea thing, but it's can you logically get from one step to the next? Delta Math has some really cool proofs, and it's nice how it helps you fill them out. So I really enjoy that. And again, it is called 2 columns because your first column is statements and your second column is reasons. Okay.